Today you will learn how you can use Matlab to run Abaqus job and extract quantities like force, displacement, etc. at a node or at a reference point. Also quantities like stress, strain at elements. You can do all of this directly from Matlab using the simple steps I am going to show you now. Few lines of Matlab codes will be required, but I have you covered. You will find those code in the description of this video. Please also check another video in our channel that shows how you can optimize Abaqus model parameters directly from Matlab. The steps involved in a nutshell are: in first step, you build the model, then add couple of lines as I will show in the input file of the model, run the provided Matlab files, and finally collect the result that you wanted. Let's start with this example of dogbone model. In this folder, I have the input file for the dogbone model that at the one end is fixed and another end is being pulled. I am interested to know the force displacement curve when this model is being pulled from this end. I need to run this code for that. Let's run this code and see what happens. So this is the code, not too long. Let's run it. So this part of the code is calling Matlab and running the job. Now the job is completed, and using a separate script that I will show you soon, the force displacement output from the simulation is being read, and also optionally I have plotted them. This is the plot of force displacement. When I ran this code, additional files like .dat file and odb file among others are created in the same folder where this Matlab file is. This happened because in this code I have defined that the current directory would be the same as the location of this script. So this gives great flexibility because as long as you have these three Matlab code and your input file in the same folder, you don't need to add any additional directory, or you don't have to set any path, not for Matlab or not for Abaqus. Line 2 to 6 takes care of that. Line 13 runs the job. There is a video link in the description that explains the function of this line. Basically, this is the name of the job, and this is the number of cores in your processor you want to use, and this interactive command makes sure that what's happening inside Abaqus, the message are shown in the command window of Matlab. These few lines will make sure that you don't get some unexpected error due to the presence of .lck file, for example. Most important part of this code is this function read underscore odb underscore output underscore node. So we have this Matlab file in the same folder. Let's open that file. This code reads the output that you requested in a particular node set that is created during you develop your dogbone model or any other model, for example. The output is read from this .dat file that has been created when you run Abaqus from Matlab, and the location of that file is in the same folder. Let's open this .dat file. You will see towards the end of this DAT file node output. This is basically the force and displacement at this end. These node outputs this is the first column, this is the second column, and this is the third column. The first column gives the node number. The second column here is the U2 or the displacement in Y direction, and the third column is the force also in Y direction. But these values is written in this .dat file after every increment. For example, this is after one increment, this value is after the next increment, and so on. So each time the values are printed in this .dat file, there is this message node output, and just right after that you have the value of force and displacement. We had to write one line of command in the input file to request this displacement and force. So the same way you can make a set of any node in your model, you can write in other outputs that you'd like to get on those nodes. The details is simple and will be clear as soon as we go through all the steps. To start with, let's delete all the files except for the Matlab files that we had in the previous folder. To request for any output, the first thing we need to do is to create an input file and put that input file in this folder. So when you use the method I'm gonna show, you will copy these Matlab files from the description of this video in a folder. The next thing you will do, grab the input file and put in here. So now I will show you all these 4 steps one by one. So let's start with the first step. In this step, the model is created and the input file is requested. You will get to download the input file for this model in the description. Nothing fancy was done during creating this model. Usual part, material, section assignment, static general steps, usual field and history output. The only thing I did is fixed these, and while I pulled this end, I pulled using this reference point, and this reference point was coupled to this particular surface. If you download the input file I am sharing, you will know exactly how these steps are done. The most important part for requesting output is to create sets directly from your model. So one of the sets I created here was RP. So RP is that particular set. And to create a set, you have to go to Tools, Set, and then Create. And then you can give this name. So in this case, I had given this name RP and selected this particular point and continue. And by that, I had this set when this dog bone specimen is pulled, the displacement of this reference point and also the reaction force that is felt at this reference point, which is a representative of the whole surface, can be requested. Not only a reference point or geometry that you can request a particular output, you can also, for example, create a set of, let's say I call it try next. So remember this name, try next, and in try next I will select this node here. So the name of this set is try next. So anyway, this is just to emphasize, to get a nodal output, a very important step is that you have to create a set and you have to remember the name of that set. So let's say first I will try and show you with this set RP, which is this one, and I will request the force and displacement at this RP set, which is this point and which is the representative of this whole end of the dog bone specimen. So the model being described, let's create a job with any arbitrary name. So let's keep it dog bone, same as previous. We have done that because depending on what name you use, you have to replace that name in the Matlab code. So as already we have dog bone, so I am just keeping the same name here. So when this job is created, so we can right click and say write input. And a input file has been created at the start in folder of Abaqus. To know the location of this input file, you have to press the Windows button in your keyboard and then type in Abaqus CAE. Right click Abaqus CAE and open file location. So in this file location, you can right click in Abaqus CAE properties and it will show you where to find the input file. So I copy this one, paste back in the folder address like here, and actually here I have this input file created. So copy that input file and paste that back here where I have already placed my M files. Open that input file and then next go at the end of this input file and find the very last line which says end step. before that line, you have to add this particular line. In this case, as we are trying to get output of force displacement at a node, so you will put this line node print, and then nset means the node set that we created and named RP, and frequency once means the output will be recorded in every increment. But soon I will show you how you can extract quantities like stress and strain at a particular element. And when you want to do that, you have to make, similarly as you did a set for a node, you have to make a set for element and then put this command instead of this, and then it is possible to request for stress and strains and similar quantities. But let's now focus only on the node print. So let's copy this line and paste right before the last line of your input file. So now here I am pasting this line. Now the name of this set was RP already. If the name was anything else, for example, try next or whatever, we can just change the name. And in next line, you will tell what output you are interested to request. So in this case, I will request U2, which is a displacement in second direction, and RF2, which is the reaction force in the second direction. If you are not sure that what is the name of different output variable, you can find that in the history output of your model. For example, in your model, if you go to history output and double click here, you can then, if set is selected specially, you can then go to, for example, stress and look at what are the code for different stress component. For example, you'll see I can populate this one. So S33 means the stress in the third direction. S22 means the stress in the second direction, and all the relevant name for other quantities like displacement and strains and so on. But if you already know that, that's fine. So in this case, for example, I know that U2 is for force and RF2 is for displacement. So what I did is just added these two lines of the already existing model input file. So this will make sure that at the set RP, the displacement and force will be printed. And this is crucial that this is printed in, because later in our Matlab file, when we want to read the ODB output from node, we will request this code to read all the node outputs from that dat file. And without this node print, these variables will not be available in that dat file. So by that, the first two steps are set it up. Now we have to run the Matlab file and finally collect the outputs. This two-line change is now saved into this input file. So let's run this script, run job and request output. So we run it and the job is has started. That's why it shows busy there. The job is still running and the files are being created, the ODB, and most importantly that .dat file that will record all this node output that later will be read by this particular script. So the job is now completed, and yes, I just missed the plot, and this is the force displacement plot. The force displacement was read by this code as I showed earlier, and optionally I have also plotted them. Just for clarification, if you remember, we have also created another node set, and I have named it try next. So for example, that node is here. This node set is try next. But anyway, I can type in try next instead of this reference point. So this was a node in the mesh, and in that particular node set, let's again request this force displacement responses. So now once it's saved, I can run this script again. The job is still running. And this is the force displacement response of that node. We can only see the displacement of that node, and we see the force is 0. This is because if we request the reaction force at a particular node, it is supposed to be 0. So the whole point of showing that is you can create any node set in your model by going to Tool and Set and Create. It could be a point, it could be in when you are in mesh, it could be a node. And once you have created that set, so you could also see that I had one set RP, I had another set try next. But what I did, once I create the input file from here, so this set is already being recorded in the input file. For example, here you can see the this try next and so on. And then it would be possible that I type in this particular line and give the name of the node set and then request for the outputs that I am interested in. One problem is that when we do node print, the most useful parameters are force and displacement at different direction that could be requested. There are other things, for example, temperature and flow related quantities that can be also requested using node print, but you cannot request stress strains and so on. To do that, you have to use something called lprint and then request and then also make a set of any element where you want to output the stress strain or similar quantities, and similar way the frequency works, like 1 means every increment. So let's copy this instead now. So I just before end step, now together with node print I can also request lprint. So lprint or element print, element set is my underscore le frequency 1. So this element set has already been created in this particular model. So to do that, I went to set, create, and then set element, and I named this one my underscore le, and then continued. So it already exists as it said. So maybe I put it underscore le2 or something, continue, and then I can select any element, for example this element, and done. And there has been so there is an element set named my le underscore 1. But let's just make use of this my underscore le. That element set was already there when I created this input file, and I can verify that this was there, like here, my underscore le. So if I have that, next I can, as I showed from history output, you can know the name, but in this case I will add that particular element request for let's say PE plastic strain 22 in the second direction, comma S22 the stress in second direction. So this input file is now ready for getting the plastic strain and stress from that particular element called my underscore le. For reading the output from element, so far I have shown out reading output for nodes. So I have also provided you with this particular code. So in this code, so instead of in this node output where I find in my .dat file where the node outputs are, and then next it reads the force and displacement or any other quantities that you requested. But in this case, it will look for element output, this message in the .dat file, and then read the next quantities which are in this case stress and strain. Another thing to notice that when we requested for node output, some of the lines here, for example 1,3, because there were, as I showed you earlier, the node number, displacement and forces, But instead, when you use element output, there are node number and some other number, and then in the third and fourth column you have these strain and stresses. So I have made some changes. Instead of this one being from 1 to 3, I have changed from 1 to 4. And also I know that the third and fourth one is according to this order. The third one is this plastic strain, and the fourth one is the stress. You can also add fifth, sixth, but this is the third and this is the fourth. In your element output that is printed in the .dat file. I will show you soon after I run this particular model with element output request. So as this time we are going to use this read odb output underscore le, let's also now just change this one to be ele. And by doing this, we can plot the in this order the third, which is plastic strain and the in second direction, and fourth, which is the stress in the second direction, third and fourth. For the same reason, I have requested this third and fourth data that's being read from the .dat file. Notice that I did not change this name, but you could easily change this name to be, for example, PE. It doesn't matter, but only thing you have to make sure that you are consistent, as well as later, for example, here when you write the function and so on. So I leave that one to you. And finally, if you have any third or fourth variable that you requested, you can just copy this one, and this would be the fifth variable. Probably after PE and S22 you have already also requested something like S33, for example. And then as there are now 5 variables, or as there are now 5 numbers, the element number, some node number, this is now PE, this is P22, sorry, and this is S22, and the next one is let's say S33, like here. So I put another, I request this code to read one more variable and then make it 1 to 5. And of course, just changing that, now you have 3 different variable requested from an element. But let's not make things complicated. We keep it as it is, or as according to the way that we have modified our input file here. And let's run the code now. So we already have requested that it reads these 2 quantities. Of course, these names are not correct, but it will not matter. This will be plastic strain and this will be stress, and from an element. Let's run this code. This is still running. So it's almost completed. Now it will read the element, and here you can see the stress and strain curve. So it is quite similar in shape for the force displacement, but if you go back and check for force displacement, this y-axis was quite high, but in this case the strain looks quite large. Let's go and look into the model, that is it really that high. So I will load this ODB output, and yeah, actually in this model I have given quite big displacement. So after a while it becomes unstable, but anyway we know that at some point here the strain was very large, and that is also reflected in this stress strain curve here. I would also like to show you how the .dat file looks, as now we have requested both a node output and the element output. Let's open this. So this is the .dat file. From here, the second Matlab code has read the element output. So it read the element output from, like every time it's found element output, it has read this first row. All the rows has these are the different nodes in the element, and all the nodes has had similar stress S22 and plastic strain. So when we run the second code, it try to find where the element output message is and read this particular line. And the first line is element number, second line is the node number. That's why we said the third and the fourth output is our PE and S22, as you can see here. So this was our PE, and this was our S22. This is PE22, and of course the name should be changed, but you can do it yourself. But for node output, it was a bit different. The first one gives the node number, and the next column gives the displacement, and the next column gives the force. You could actually have requested for multiple and then just modify. Now we are talking about node. So as you can see, the second one is for displacement, the third one is for force, and similarly you can add more and just change this one. If you add one more, for example F11, you just have to write it 1 to 4, because then it will have 4 column, and put after space just put another %e. That means one more variable to read. So of course you have to do it here, but we don't need it now. And eventually also request that particular output here, and that should do it. I guess you are expert enough to read this very simple file. I hope you can make modification, but if anything seems unclear, just write it in the comment. I will try to clarify. The work we did so far of printing this output and in some cases plotting could simply be performed requesting the history output in the Abaqus model itself. But the advantage of using this method is that you can extract any variable that you want, and then if you want, you can use those variable to do whatever calculation you want to do. For example, if you want to calculate the area under this curve, probably you can just do it doing traps, and then it gives the area under this curve, or in terms of in other terms the energy. Then with this energy, maybe you want to do some additional calculation and take some decision, and based on that output you may change something in your input file and run the job again. And this could allow you to do a parametric study that will allow you to do optimization in certain parameter that actually you cannot do if you just run the job from Abaqus. In next video, I will show you an example of a very simple optimization of material parameter using this output reading technique that I have shown in this video.